from the sessions here. And finally, these sessions are really meant for problem solving, which means that you're going to learn how to think about a problem that you've never seen before, how to start from scratch, and how to set up the stage in your head, and to think through some of these questions. So that's roughly the big picture. If you are in any of these, if you answered yes to any of these questions, then you belong here. Now, many of these sessions, you may not understand everything that goes on. That should not discourage you, because this is a process. Over time, you'll find that you understand more and more of what we talk about here. And soon you'll realize that your skill level is actually comparable to some of the best students we have here. And even if you're not comparable to the best students, if your skills have improved, then we have achieved what we wanted to achieve. So the goal is to get better, and if possible, to be able to compete not either with yourself or with other people, and to do this together as a team. So that's what these sessions are all about. As I did mention before, part of what I want to do is to train you for programming competitions. Now, if that's not what you're interested in, that's completely all right. But this is part of what I'd like to do. I'd like to form teams so that FIU can compete in many programming competitions, either in the city, in the state, in the region, nationally or internationally. And an exciting thing that's going to happen pretty soon is a programming competition that will take place on February 25th in PG6, in the tech station across from the computer science building on the campus of FIU. This is really exciting. We've been doing this for now 5 or 6 years. So to have a competition right in-house is very, very exciting. These competitions are great. They bring people, they bring about 30 to 40 teams, and these teams compete with each other for 5 hours, solving a lot of really hard problems. And soon you'll find that your skill level really will put you in a place where you can start to compete with the best teams over there. And in order to prepare you for this, we will go through many of the things that we do, namely problem solving, how to think about things, how to write pseudocode, and then finally how to convert them into workable Java code or Python code or whatever programming language you want to learn in. We do not focus on any specific programming language. Most of the time I'll be talking, at least in the Wednesday sessions, I'll only be talking about pseudocode. Pseudocode is such that you can convert them into real code, either in Python or in Java or in any other language that you choose to write your programs in. So these sessions are not designed to train you in one specific language. They are designed to train you in a generic manner, both for thinking about problems and for solving them, and for solving them efficiently. Now, in order to train for this programming competition that's coming up, I'll be spending the next 5 weeks on specific topics. Some of these topics are likely to be hard. After the competition is over, we'll go back to some of the basics and start start to do some things that are simpler than what you might see over here. What is also important for you to understand is that these Wednesday sessions are complemented by mock competitions that we run on Sundays. So every Sunday between 1 p.m. and 6 p.m., we will set up mock competitions where you get a handful of problems to solve. For these problems, you read them, you understand them, you come up with an algorithm, you code them up, and then there will be an online place where you submit your solutions, and it will tell you whether your solution is right or wrong. If it is right, then you move on to the next problem and keep going. If it's wrong, then you go and fix it and you resubmit your solutions. We will do a whole bunch of such competitions between now and February 25th. In fact, we'll do that throughout the semester. But in particular, the next 5 weeks will be training for this programming competition that will happen at FIU on February 25th. If you're interested in competing, then the first thing I need you to do is to register at the website that I've given you here. ICPC stands for Intercollegiate Programming Competition. And if you go to icpc.global/login, you can register. And once you're registered, send me or Ricky your registration ID, and I will make you part of one of the teams that we will then post. We will then have at the programming competition. If you're interested in looking at some of the recent competitions, regional competitions that we've had, you can go to the website that's there at the bottom of this page. These slides will be made available to you. So if you don't manage to copy these websites, no harm done. I'll make sure that you get these slides for you to look at. So as I mentioned before, we do these training sessions every Wednesday from 3:30 to about 4:45. During these sessions, we focus mainly on our big problem solving. On Sundays, from 1 to 6, we do mock competitions, and then my main assistant, Ricky Luis, who's sitting in the audience there, he will run a session for beginners, trying to explain some of the problems that you saw at the competitions. He hasn't decided what time of the week he will do those sessions, but we will make those announcements sometime in the near future. Ricky, have you decided on the time and date?
No, not yet. I'm right behind the computer, okay. So you can't see me. But
okay, no problem.
I will announce it.
Okay. Now, another way to prepare for the February competition is a warm-up competition. This is called the North America Qualifier. Even though it's called a qualifier, it's not really a qualifier. It's just a warm-up competition. This happens on February 4th. That's what, 2 weeks from now, roughly speaking. So I again recommend that you register for this competition, just to kind of get a feel for what these competitions are all about and what kind of problems there are. For most of these competitions, there are at least 1 or 2 fairly simple problems where most of you can at least attempt, and it's a great experience to be able to go through this process. There's a comment on chat here. Okay, thank you. All right, so the registration deadline for this North America qualifier is February 2nd. So please make sure that that you register if this is of interest. There are more details about this qualifier round at the website that I have on the slide. Again, I will provide this to you very quickly. So, in order to, I already mentioned this, that every Sunday we will do mock competitions, but really for the next 5 weeks, we are thinking of setting up 2 mock competitions, one on Saturday and one on Sunday. If there is sufficient interest, then this is something that will get you really interested. So the general goal is to have some intense training for the next 5 weeks. Then after that, we will slow down and try and learn things in a more systematic way for the remainder of the semester and also for the remainder of the year. There are a whole bunch of topics that we end up covering. The first topic are math type problems, things like permutations, combinations, probability, etc. Then we look at something called dynamic programming. If you haven't heard of this, no harm done. We'll talk about this in great detail. Then we'll talk a lot about graph algorithms and tree algorithms and some advanced graph algorithms. And then finally, there are a whole bunch of miscellaneous topics, including geometric algorithms, string algorithms, number theory algorithms, integer programming algorithms, optimization algorithms, Diophantine equations. So a whole slew of really fascinating problems that we will end up touching upon and covering during these sessions. Overall, what we will find is that problem solving involves gathering a bag of tricks that you can then use in order to solve new problems that you see. So there is no set curriculum that we will follow. We will kind of work on whatever people are interested in and whatever makes sense in terms of the skill level of the class. In order to prepare for this problem solving, there is this amazing repository of problems that you can solve. This repository is called VJudge. You can go to this website that you see on the slide, and there are literally thousands and thousands of problems for you to look at and for you to solve. Not only do you have a repository of problems, but you can also upload your solutions, and it will instantaneously tell you whether your solution is right or wrong. For many of these problems, not only do you have to upload a correct solution, but you also have to upload an efficient solution. So that means that not only do we have to learn how to design algorithms to solve the problems correctly, we also have to learn how to design algorithms that are efficient, that run quickly, that don't take too long in order to finish the computation. I did mention that you will learn teamwork. Now, one of the reasons to do teamwork, or one of the ways that we will foster teamwork, is that these competitions that I mentioned earlier, the one on February 4th and the one on February 25th, all these competitions involve teams of 3 people. The interesting thing is that even though there are 3 people working in a team, you get only one computer to work on. This computer will not have access to the internet, so you can't search for solutions and figure things out. It's all in your hands once you're into the competition, and then this team has to. You'll be given a set of 8 to 10 problems, and you can decide who works on which problem. You can decide who will code up which problem. You can decide who will debug which problem, but you have access to only one computer. So at any given time, only one person can be sitting there typing away the code for whatever problem you're solving. While one person is coding things up, the other people can solve the next problem if they want to. So this is part of figuring out how to work as a team, figuring out who has skills in graph algorithms, or who has skills in data structures, or who has skills in combinatorics, and figuring out who will be solving what problem and who will be writing up code for what problem. What I'd like to do is, for those of you who want to compete with the FIU teams, either for the February 4th qualifier or for the February 25th competition, I'd like to form teams of 3 so that you start to work together, you start to get to know each other, you get to know each other's strengths and weaknesses, and you figure out how you can be really effective as a team. One of the important skills for you to learn is how to debug not just your program, but other people's programs. And this is a skill that only comes by working as a team. That's a skill that will be very useful for you when you go start to work in a big company and work as part of a larger team. There'll be people who will make mistakes, and it will be your job to figure out what that bug is and how to fix it, because you're a team there. If your team doesn't succeed, you don't succeed. This is where some of that teamwork really starts to become important. It's great to form teams where you have complementary skills. It's great to have somebody on the team who has good math skills. It's great to have somebody who has good programming skills or debugging skills. And then it's good to have somebody who knows a lot of algorithms and data structures. But even if you don't have strong team members, you can still form teams and start with simple problems and gain experience over time. Overall, you'll see that you learn from each other a lot more than you learn from me or at these sessions or at some of the other sessions that we will do. I did already mention that it's a great skill to know how to debug someone else's program. In order to be able to compete for the programming team, there are some eligibility considerations, and I'm going to make this available on Discord for all of you to verify before you register and tell me that you want to compete on the programming team. Then finally, one more important piece. At the competition, I mentioned that you will have a team of 3 people, you'll have one computer, but I also mentioned that you won't have access to the internet, you won't have electronic media, you won't have your cell phone, you won't have your laptop, but you can take there a notebook that's 12 inches by 12 inches dimensions and has a thickness of 2 inches. You can take notes of whatever it is that you want. You can print out code for problems that are standard, and you can take it there and use it during the competition. So these are the ways that you prepare for a programming competition. Overall, it's an exciting experience for any of you. For some of you may have done this during your high school periods, during your high school years. But if you haven't, it's still quite all right. This is a good time to challenge yourself to try out at these competitions. And it's also important to learn not to get dejected by hard problems. To understand that you're not going to be able to solve every problem out there. To understand that you have some limitations which you can improve over time. So these are all things that come about as you prepare for these competitions and as you work with us and improve your overall skills. There are a whole bunch of different books that can help you to prepare. I have mentioned 4 of them here. There are actually quite a few more. Again, I will see if I can make some of these books available to you during your competitions. I will have Ricardo or somebody keep some copies that you can perhaps take and either photocopy parts of it or read through them quickly. You could also purchase some of these for yourself. One of the books that I would recommend is the second book here by Halim and Halim. This is an excellent book that gives you a complete set of solutions. And the book is such that you can actually take the book itself to the competition. It's fairly thin, and it has a complete set of solutions for many of the standard problems that we're looking at. So, in summary, even though programming competitions are not necessarily the only thing that we are here to train for, I'd like to try and convince you that this is a good place for you to start. So I request you to put February 25th on your calendars, and also February 4th, which is the North American qualifier. Register for these competitions and make sure you keep the entire day free to compete with us, to compete with FIU's team, and to show people what FIU is really made of. This is a good place for me to stop and see if there are questions that I can answer. So somebody has asked the question, are all these competitions you mentioned remotely too? So the Sunday mock competitions can be worked on remotely. However, there is a core part of the team that meets in room 241 on Sunday at 1 p.m. The good thing about being there physically in person on Sunday is that there are a whole bunch of people. You can talk to them. You can get ideas for how to solve various problems. You can learn from them. You can learn from some of the mistakes they have made. So there's a lot more interaction. There's an entire community of these programmers and problem solvers that you can find over there. And over time, you'll start to know whom you can go and ask for help. Ricardo and Yash are the two assistants. They're both master students from FIU. They should be there on every Sunday. So it's a good time for you to go there in person. Even if you don't go there in person, they are available on Discord and by email if you have questions for them. The programming competition on February 25th is an in-person competition. It's not a remote competition. The qualifier on February 4th, I am not very sure. Most likely it's a remote competition because there are no stakes there. It's just a practice round for the February 25th conference. I see a couple more questions here. Okay. Are the weekend competitions on VJudge? The answer is yes. All our competitions are on vJudge, and on Discord we'll tell you how to find our competition and then how to go and start to solve the problems that we set up for you. And you can compete in these weekend competitions even if you're not an FIU student. You don't have to be an FIU student. All you need is the name of the contest, and then you just log in there and start to compete with the other students. There will be a scoreboard, and your name will appear there if you've solved any problems, and you can see how you compare with some of the other FIU students or the ones that are competing on that particular competition. Are there other questions for me? Any questions from the audience? The Wednesday session is also online. I am out of the country for the next 2 weeks, so I will hold these sessions online over Zoom, and I will make the recordings available. Will they be online after I'm there in person? We haven't quite made that decision. We will let you know. Most likely the answer is yes, because what we found over time is that more people do make use of these sessions and do attend these sessions if they are made remotely available. However, I'd say that it's a lot easier to slack off and not pay attention if you're only online. If you're there in person, it's going to be very hard for you to ignore me and play with your cell phone. So you will end up learning a lot more if you're there in person in room 235. I did mention in the email that there are scholarships for people if you train with us. In order to be eligible for these scholarships, I need commitment of time from you, which really means that you commit to working with us on Wednesdays and Sundays, both for the problem solving session as well as for the mock competitions. And you are part of one of the teams at the February 25th competition. If you compete in these, and if you're consistent in terms of training with us, then you would be eligible for one of our scholarships. Does that answer your question? Great. Any other questions? I don't see a hand up there. All right. So if there are no more questions, we are going to talk about something else today. One more question. I found it. Right, so somebody asks, how can they know more about these sessions? If you got the email, I sent out an email on the FIU, on the CS events email. So every student should have received it. In that email, I have links to the Discord channel. I have links to the Google Developers Club. Both these, once you register, you will get regular updates on these sessions, and so you should know, you will be updated on whatever it is that we do over here. On the Discord channel, you'll have all your teammates over there, and you'll be able to to talk to them and figure out what is going on and what you may have missed during any of the sessions. So I can't add you to the list. I need you to go and register there and get on the list. Ricardo, is that correct? That they get on the Discord channel and on the GDSC members club?
Yeah, that is correct.
Okay. And both those links are in the email. If you don't have it, then talk to Ricardo and he can get that to you. Here's another question. It says, we do not focus on the language. The VJudge website allows you to submit programs in one of many languages, and it already includes Python, C, C++, and Java. It also has a few other languages that I'm not familiar with, but if you have any specific needs, you're welcome to go and check over there. If you're going to be forming a team, it's a good idea for you to talk to your team members and make sure that you all are comfortable in one programming language so that you can then work together as a team a lot more easily than if one person writes in Python and the other writes in Java and the other writes in C++. So make sure that you have something in sync before you form teams. What I also recommend is that before you leave the class today, see if you can talk to the other people in the room and form a team so that you will have something to so that you'll have a team to work with on this coming Sunday and as you prepare for later sessions. Any other questions? All right. Okay, so if we don't have any questions, how am I doing with time? All right, so I have about 30 minutes or so. So I'm going to talk about a topic that seems to show up quite often in these programming competitions, and this topic is called Catalan numbers. So the work on Catalan numbers is attributed to this Belgian mathematician called Eugene Charles Catalan, and he's from the 19th century, and this Catalan number, so he invented these numbers called the Catalan numbers, and it arises in many counting problems, in many combinatorics problems. You can read more about it if you follow this link, but really today I'm going to give you a quick introduction to this topic, and you'll see that over time you'll see that there are many problems which basically involves finding these Catalan numbers, and once you know how to recognize these problems, you'll find that it's actually quite easy to code this up and find the right answers. You can also read our Catalan numbers on the Wikipedia page. So here's the first problem that actually involves Catalan numbers. It's called the balanced parentheses problem. So here's the question. Remember, these are counting problems. So imagine that you're given n pairs of parentheses, and you're asked the question, how many different ways can you write down valid parenthesized strings? What this means is that for every open parenthesis, there has to be a close parenthesis, and so I should be, let me write down a few examples of valid things and invalid things. So for instance, this here is a valid parenthesized string. This here is also a valid parenthesized string. This here is another one that's a valid parenthesized string. By the way, all of you can see what I'm writing, correct?
Yeah.
Okay. However, this here is not a parenthesized string. Even though you have two open parentheses and two closed parentheses, it's not a valid one because why would this be invalid now? Anyone?
Yeah, you can just talk.
Go
Oh,
ahead.
okay, yeah. Oh, by the way, Dr. Giri, this is this is Michael.
Hey, hi, Michael.
Yeah, hi. Yeah, anyway, it's not valid because the last open parenthesis doesn't have a closing parenthesis.
No, everything has a closed parentheses. There are two open and two closed.
Well, I mean like the very last one that you wrote, that's an open one.
Well, I could change that to, let's say, this. Now what? Is it valid?
No.
Why not?
Well, you're still missing a closing parenthesis.
Every open parenthesis there has a matching closed parenthesis.
They can have the same matching. They
Sorry,
have to have unique. They have to have unique matches. Each one.
there's a unique match. I matched the first open with the first closed. What's wrong with that?
The second close count.
That's good. But what about the third and the fourth?
Everything is matched. I'm going to match, let me change the color here. I can match this open with this closed. I can match this open with this closed. And I can match this open with this closed. What's wrong?
You need to check the order.
Uh-huh.
From,
So what's wrong with the order?
from left
We need to
to
face each other.
Sorry?
from left to right,
Okay.
you should never have more closed parentheses.
Very good. So a valid parenthesized string must always have, must never have more closed parentheses than open parentheses in a prefix. Okay? So you may have some unmatched open parentheses, but you can't have unmatched closed parentheses. And so that's how you define valid parenthesized strings. All of you were right. It's more a matter of how you define this and how to be precise about this. So valid one is one that has equal number of open and closed parentheses, but that's not good enough. You also need the second condition that you just said, namely any prefix must have at least as many open parentheses as closed parentheses. You could have more open ones, but you cannot have more closed ones. And so here's another example of a valid and an invalid one. So now the question is, how many different ways can you write valid parenthesized strings? And it turns out that this number is basically a Dikataran number. And we're going to try and see how this comes about. And we'll try and write down the actual answer. Are there any questions before I move on? Okay. Here are some examples of balanced parentheses, of valid balanced parentheses. So if n is equal to 0, which means you have n open, 0 open and 0 closed parentheses, there's only one way to write this, and that's the empty string. If n is equal to 1, you want to know how many different ways you can write one open and one closed parentheses. Well, there's only one way to do it, because you have to open with the open parentheses and then you have to close it. However, if n is equal to 2, there are two different ways to do this. You can open one, close it, open a second one and close it, or you can open 2 and then close 2. So there are two different ways to do this. Then here are the ways you do for n equals 3, then you have n equals 4, n equals 5. You see that these numbers actually grow very, very quickly. The numbers that you see on the right-hand side, 1, 1, 2, 5, 14, and 42, these are your Catalan numbers. And we'll see how to write down a formula for figuring out this number. That's what we're going to talk about. These are your Catalan numbers. The first few were 1, 1, 2, 5, 14, and 42 we saw on the previous slide. Here are some later numbers for n equals. So this was 0, 1, 2, 3, 4, 5. This is 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 18, 21, 23, 25. So this last thing is the 25th Catalan. I see that there are questions, so let me see what the responses were. You guys were answering my previous question. Sorry about that, I didn't see it until that. Right. Okay. Now, we're going to try and write down the definition of a valid parenthesized string in a different way. The first thing that we know is that if there is a valid string, it cannot open with a closed parentheses. And this is because of the condition that we wrote down. So therefore, every valid string must open with an open parentheses. Therefore, if it opens with an open parenthesis, somewhere later on, there must be a closed parenthesis that matches with it. And this allows us to make the following claim. What we're going to say is that every valid string must look something like this. It must start with an open parenthesis, and somewhere down the line there must be a matching one, but in between, whatever you have must be a completely balanced string. You can't have more, you can't have some imbalanced stuff within A. But then you could also have some things after the matching parentheses for the first opening one. We'll call that the string B. What it says is that every valid parenthesized string must look like this. It has to have a it must start with an open parentheses, and then it must have open parentheses A, close parentheses B. A and B are valid parenthesized strings themselves. So this gives us what's called as a recursive definition of a valid parenthesized string. If you can write down such a recursive definition, then it's possible to write down a formula for the number that we are trying to compute. Remember, we are trying to count how many different ways we can write valid parenthesized strings. Here it's important to point out that A and B may or may not be empty. Okay. It's also important to know that if this whole string had n open parentheses and close parentheses, then if A has k pairs of open and closed parentheses, then B must have n minus k minus 1 pairs of open and closed parentheses. Remember, A and B are valid strings, and therefore they must have k complete pairs of parentheses. And so we have already counted 1 here. If A has k, then this part here must already include k plus 1, which means B must have the remainder, and that's n minus k plus 1, which is the same as n minus k minus 1. If you know this much, then it is possible to write down this recurrence formula, which says the number of, if you call C subscript n as the nth Catalan number, then C of n is C0 times Cn minus 1. So it says it's possible that k is 0 and b is n minus 1. It's possible that k is 1, in which case b n minus k minus 1 would be n minus 2. And so this tells you how many different ways it is possible to write down a valid parenthesized string. So either it's going to be C0 times Cn minus 1 or C1 times Cn minus 2, and so on and so forth. And then you add up all of these. That's the number of different ways that you can create valid parenthesized strings. So all this essentially came from trying to understand a precise definition of these balanced parentheses. So we're going to talk about a slightly different problem. By the way, you can use this formula now to quickly compute C of n. And remember, we wrote down here the first n, Catalan numbers. You can apply the formula and verify that these numbers are correct for you. It's quite easy to verify this, so I'm not going to do that over here now. But that's what this thing tells you. We're going to look at a slightly different problem where again Catalan numbers show up. Imagine that you're trying to get from one corner of this blue square to the other corner. So you're trying to go from this end of the square. Let me make this red. You're trying to go from this end of the square to this end of the square. And you're allowed to go only using the shortest possible path, which means that you can either go right or you can go up. If you ever go left, then you're going to end up with a longer path, and these are not allowed. Now, what we want to do here is to count the number of ways I can get from this end to this end here without ever crossing this diagonal. Okay, so that means this is one possible path. You're going all the way to the right and then all the way up. So that's one path. Here's the second one where I go 3 steps right, 1 step up, 1 more step right, and then 3 steps up. Then here's another one, here is another one. Each of these paths is a different path, and you see that each one never crosses the diagonal. If you want to know how many different paths there are that go from this end to that end, never crossing the diagonal, it turns out that again, this is the Catalan number. And I'm going to show you how that comes about, but it's useful for you to try and think about this. Another way to actually think about this is that each of these solutions actually is actually very similar to the parenthesized expressions that we talked about. Remember, in the earlier problem, we were counting how many ways we can write valid parenthesized expressions. Over here, it turns out to be very similar. I can think of of going right to be the same as the open parentheses. And I can think of going up to be the same as a closed parentheses. What you'll see is that if we never cross the diagonal, then your path simply corresponds to a valid parenthesized expression. So over here, we have 4 right arrows, which means it's 4 open parentheses. And then we have 4 arrows going up, which is the closed parentheses. And so this one here corresponds to that parenthesized expression. Is this making sense?
Yeah.
If you look at the second one here, what would be the parenthesized expression now? I would have 3 right arrows, which corresponds to what?
Open parentheses.
3 open parentheses. Then after that, I go 1 step up, which means I have 1 closed parentheses. Then I have 1 more right arrow, which means I have 1 closed parentheses. And then I have 3 closed parentheses. Does that make sense? So I have taken each of these paths. I've taken this path here. Then I've taken this path here. And I've converted them into parenthesized expressions. Did that make sense?
Yes.
Now, why do each of these correspond to this idea of never crossing the diagonal? At the diagonal, your number of open parentheses equals the number of closed parentheses, right? So if you never cross that diagonal, it means you're never going to have more closed parentheses than open parentheses. Does that make sense? Say, for instance, you did look at this example here. I am doing 2 open, 2 closed, then 2 open and 2 closed, right? So that corresponds to 2 open, 2 closed, and then 2 open, and then 2 more closed. So here, if you look at it, at this point, all your things were already balanced, and that's why it touched the diagonal here. So anytime you touch the diagonal in your path, your open parentheses and your closed parentheses must balance out, and you can forget about it. So if you ever cross this diagonal and go further, then the only way for you to do this is by going up, which means you have 1 extra closed parentheses without an open parentheses. So that's why each of these paths is exactly the same as a valid parenthesized expression. Did that make sense?
Yes.
So what I'm trying to tell you is that the number of ways of writing down balanced parentheses, valid balanced parentheses, is exactly the same as the counting the number of paths going from the left bottom to the top right without ever crossing the diagonal. What we have done is to find an exact correspondence between valid parenthesized expressions and paths on this grid. And so therefore, the counting problem turns out to be the same. What you'll find is that there are many such problems where they don't look the same, but actually they are the same. And if you can count one you can count the other. And I'm going to show you some more examples of how this happens, and hopefully this will start to make sense for you. Any questions from the audience?
I have a question. So
Yeah.
this is valid only if the grid is n cross n, like it's a square, right?
Correct. Correct.
If it's a rectangle.
So I'm going to show you. Yeah, I'm going to show you how that happens. Yeah. For that, the condition is slightly different, but I'll show you how that happens. The counting happens a little differently, but for that we need to start. I have to tell you the solution, and then we'll come back to it. Okay. Give me a couple of minutes, and we'll see this. All right. So let's look at some more. There are some questions here. Some of you think it's pretty cool. That's great. Glad to hear that. Okay. By the way, here you'll see the same thing. It tells you how many ways there are of going in a 1 by 1 square, in a 2 by 2 square, and a 3 by 3 square. And you'll see the same numbers happening again. N equals 0 is 1, n equals 1 is 1, then you have 2, then you have 5, then you have 14. The next one is going to be what? What is n equals 5? 42. Okay? So, let's try and understand. Let's forget about the parenthesized expression problem. Let's figure out how we're going to do the counting of these strange paths. Before we do that, we're going to try and count a simpler, we're going to solve a simpler problem. The simpler problem says, I want to go from one end of a grid to another end. Come on. You see this blue box on the right-hand bottom here. This time, unfortunately, I'm going to go from the top left to the bottom right. I've just turned the box around, but it's really still the same. I want to know how many ways there are of getting from this point, let's call this A, to point B. And but I'm allowed to use only shortest paths, which means I can either go right or I can go down. But here I don't really care about crossing the diagonal or not crossing the diagonal. The diagonal, you can ignore it for now. I just want the simpler problem of counting how many ways I can get from A to B with shortest paths. So think of this as a gridded street. Think of this as Manhattan, and you want to go from your home here to a restaurant somewhere here, and you want to count how many shortest paths there are to get from the home to the restaurant. Of course, I could go this way. I could go this way, or I could go this way. All of these are valid shortest paths, and I want to know how many such paths there are. Yeah, I could even cross the diagonal and go this way. I could even go this way. All of these are valid paths, and I want to count how many there are. Is the problem clear to everyone?
Yes.
Okay, good. So it turns out that even though this problem looks kind of hard, there's a simple way to think about this. And the simple way to think about this is as follows. In order to get from A to B, think of A as your origin. Think of A as, give me just a second. So it turns out that the answer for this is 2n choose n, and I'm going to explain why this is so. So every path from A to B has 2n steps. If you think of A to B to have the coordinates 0, 0, if you think of A to have coordinates 0, 0, then B is going to have coordinates n, m, right?
I think I understand. So, like, you have either the choice of either going right or going down. That's why it's 2n, right?
Yes.
And then the choice is how many steps it takes to get to the end. Okay, so since the 4x4 grid, it would be, let's see. Okay, so it would be 8 steps, right? So it would be, n would be 1, the choice would be 4, and would be 4 squared, right?
Let me help you think through this. That's not the way to go about it. Here is a more structured way to think about this, okay? So first of all, we know that every path has exactly 2n steps. Why is that? Well, this has coordinates 0, 0. This has coordinates n, n. So therefore, in every step, either your x coordinate goes up by 1 or y coordinate goes up by 1, right? So therefore, you want to increase the x coordinate by n, you want to increase the y coordinate by n. It doesn't matter in each step whether you increase the x or the y. You have to increase both by n, and so therefore there are going to be 2n steps. Are we okay? Are we all clear about this?
Yes.
Then I know that there are going to be 2n steps. Of these 2n steps, n of them must go right and n of them must go down. You cannot have anything that goes left, or you can't have anything that goes up. And that's because if you do that, you won't get the shortest path. So now what I'm going to do is the following. I know I have 2n steps, so I'm going to put down 2n boxes here. So in this case, I have n is 4, so I'm going to put down 8 boxes. Okay. So that's 1, 2, 3, 4, and so on, all the way up to 8. So I have 8 boxes. What I know is that in my first step, I can either go right or down. In my second step, I can go either right or down, and so on and so forth, right? However, I can only make n right steps and only n down steps. So imagine that I pick which of these 8 steps I'm going to go right. So let's say the first one I go right, the third one I go right, and the 6th one I go right, and the 7th one I go right. Now, if I decide that these steps are going to be right, then all the other steps are decided for, because I've already chosen n steps going right. All the other steps have to be down steps, right? Is that clear?
So,
So, hold on,
This-
just tell me if you understood it.
understood.
So these are going to be down steps. You don't have a choice on it, because you can only have 4 right steps. Is that correct? Is that clear? So every path must have 4 right steps and 4 down steps. Once you decide which 4 are right steps, the other 4 are going to be down steps. Now, all you have to decide is which 4 are going to be right steps. But you can place them anywhere you like. Since there are 2n of these steps, all you have to do is to pick any n of these as your right steps. And that's why you get 2n choose n. Of the 2n steps that you have here, so this is 2n, you're picking n of these to be right steps, and all the others are immediately decided. So you have choice of only 4 of them. And that's why if you know how many ways you can pick n out of 2n, then you would have counted how many ways there are of getting from A to B. Did this make sense?
It does.
Okay,
I have a question.
yeah.
So basically, what you were saying is, I mean, you could choose like in other words, it doesn't matter how many right steps you choose, right?
Oh no,
Yeah, I
you
guess.
said exactly there are n right steps, not how many.
So you have n. Okay, you have n right steps. Like in this case, you put 4 right steps. But my question is, so does it have to necessarily be?
Well, I put 4 because n is equal to 4 here. Remember, this is 0, 0, and 4, 4, right? There are 4 right steps and 4 down steps, right?
Oh, that's right. Yeah. Oh, because
This is a 4 by 4 grid, and so n is equal to 4, right?
Right. Okay.
Basically, your number of right steps and down steps are gonna depend on the size of your matrix.
Oh, it's just dependent on the size of the. Yeah, because what I was
That's
thinking,
right.
because what I was thinking
That's
is
the
like to get
shortest
from point
path.
A to point B, like to get from point A to point B, you don't necessarily have to take the same number of right steps as down steps. Yeah.
But that makes
Okay.
the shortest path. So you.
Oh,
have
that's
to-
right. Yeah, that is the shortest step.
Yeah.
Yeah. Yeah.
That's why we're doing this.
Yeah.
Okay, I think I got it now. Yeah, you go down
Okay.
4 and right.
So whatever that n would be, this is 2n of these steps. Of these 2n steps, you get to decide which n of these are right steps, because all the others are going to be down steps. And there are 2n choose n different ways of doing that.
Is the answer for this problem 42?
No, it's
Or
not.
44?
No. This is not a Catalan number. So no, you're going to confuse people. Just throw that. This is simply, remember, this is a different problem. In the Catalan number problem, you cannot cross the diagonal. Here, you're allowed to cross the diagonal. This is a different problem.
So would it be 56 then?
I'd have to figure it out. So it's 8 choose 4. 8 choose 4 is 8 times. So you have to do the math. 8 times
Oh, wait,
7.
8 choose 4? Oh, wait, hold on.
It's
I
8
got
times
you.
7 times 6 times 5 divided by 4 times 3 times 2.
Okay, then the answer is not. Wait, no.
Forget it. It's some number. It's irrelevant. You're sending us down some different path. You need to focus again here. Don't focus on the numbers. Focus on the methodology we are using. All right. The methodology is that the answer comes from the number of combinations that you have. And the number of combinations comes about because you have 2 n steps of which you get to decide which n steps involve going right. And therefore, there are 2 n choose n different ways of choosing those.
Alright.
Okay. So therefore, this simpler problem is simply a matter of 2 n choose n. Now, if you want to count the number of ways of getting from A to B that do not cross this diagonal here, that's a different problem. Now you have counted way more than before because you allowed this diagonal to be crossed in this count. 2 n choose n includes a whole bunch of paths that cross the diagonal. And we're going to figure out how many those are and remove those. So there's a little more work to figure this out, but I wanted you to understand this, this particular problem. Now, I know I'm almost out of time, so I'm going to tell you about one quick problem which somebody asked, namely, what if this is not a square grid? And you'll see that the answer is immediate. If it's a non-square grid, then this end of the square is going to be at sorry, I showed you the answer. One end is at 0, 0, the other end is at n comma n. So therefore, there are n right arrows and n down arrows. So what do you think is the answer?
N plus n, choose n.
Wouldn't it be n over 2 or m over 2? Like, you know, like.
Can you hold on? Can you hold on and let other people answer, please?
N plus m, c choose n.
That's right. So you have to count how many steps are required in a shortest path from one end to the other. Since there are n along the horizontal direction and m along the vertical direction, any path is going to have n plus m steps. Of these n plus m steps, n of these steps are going to be right arrows. And so therefore, the right answer is n plus m choose n. And you'll see that if m is equal to n, this becomes the same as the previous answer, which is 2n choose n. Now, these are all combinatorics problems. I know we are out of time. The Catalan number actually requires one more step, and it turns out that it's 2n choose n minus a quantity. It's a little more involved. I won't be able to explain that in a short time, but you can try and figure that out for yourself or read about it in the link that I gave you. We're going to stop here for now. I do want you to know that there will be a mock competition on Sunday at starting at 1 o'clock. If there is a competition that we set up for Saturday, we will let you know by Discord, over Discord, whether that's going to happen. But please stay tuned and please register for the upcoming competitions. Do see if you can form teams as quickly as possible, because I need to register your teams for the February competitions. For the North America qualifier, you can just go and form your own team. You don't have to tell me about it. But for the ICPC competition, I need to know who your teams are. I need to register you and I need to pay for it. So please let me know before you go and become and decide who your teams are. Ricardo and Yash, is Yash there?
Yeah.
Good. So Yash and Ricardo are both assistants for these programming team sessions. Do talk to them if you have any questions, and do ask for help if you want to register for these competitions. They can help you find a team or find team members who will complement your skills. So do contact them for further information. At this point, I'm going to stop here, and we'll talk next Wednesday at the same time. Are there any questions before you all leave?
Just a quick question about the last one. So between N and M, N should be
Yeah.
the smallest, right?
Sorry, say that again?
So N and M, the first
Yeah.
one, we choose N, right? Which is the smallest of those two numbers.
Ah, very good question. Yeah, so actually this is what it turns out to be. N plus N choose N is actually the same as N plus M choose M. If you write down the formula for combinations, go and look up your book if you don't remember this, you'll see that both these numbers are the same. So it doesn't matter whether you choose N things or you choose M things. Did that make sense?
Yes.
Okay. Yes, Adriana.
I'm sorry for being impolite. I'll try to be better next time. Also, thank you very much for giving us the review.
Oh, you're welcome, Adriana. It's my pleasure. Somebody asked, should we review anything in specific before Sunday? There's really nothing to review. As I said, there is no fixed curriculum. We are going into the competition somewhat unprepared. So your goal should be to see if you can solve one or two problems, at least the easier ones over there. There are going to be other people. Seek their help. They will help you to identify the simple problems and focus on them. Make sure you learn how to write correct programs, how to submit them on VJudge, and getting your solutions accepted. Once that's done, then you over time you can go and try them on at least for the Saturday and Sunday mock competitions. You can work individually or as a team. There are no restrictions whatsoever. The ICPC competition is on the 25th. That's correct, February.
The slides will be posted on Discord, Professor?
Sorry, say it again?
Will the slides be posted on the Discord server?
Yeah. Well, let me talk to Ricky and figure out the best way to get them to you. Okay?
Okay. Thank you, Professor. Appreciate your time.
You're welcome. Of course, you're welcome. Ricky, is there a website where we can keep these things, or
Yeah, I can
what's
set
a good way
something
to
up.
get?
Sorry? I can probably make a Google Drive and then just store
Okay.
everything there.
All right, that sounds good. Yeah. And then you can share the Google Drive with on Discord.
Yeah.
Okay, perfect. All right, folks, thank you so very much. See you next week.
Thank you, Professor.
Thank you,
Thank you.
Professor.
Thank you.
Have a great day.
And if anyone wants to compete for ICPC, if you have a team, you can just email me or send me on Discord your team. And if you don't have a team but you still want to compete, just send me your information and I'll group you up with someone, with a couple of people.
Privately through Discord?
Through Discord or general chat, either or.
Okay.
Yeah. Peace out, Demba.
Do we have to join using this link? Just
Right there.
I have it in
Yeah.
this.
Ask you a quick question.
Yeah.
The 2N choose N.
Yeah.
It was 8 choose 4 because it was 4 by 4 grid, so it was 2 times 4. Is that why it was 8 choose 4?
I mean, it was 8 choose 4 because you have a total of 8 different positions,
Mm-hmm.
and then 4 of them were chosen to be.
It was 2N, or yeah, 2N choose N, right?
Yeah.
So you have a 4 by 4 grid, and you plug in 4 for the N, right?
Yeah.
And so it's 4 times 2, and then down there it's like you choose 4.
Yeah, exactly.
So if you had a 3 by 4 rectangle, and it's
Mhm.
N plus N, you would have 7, right? So would it be 14
3? Yeah.
choose 4? 14 choose 4?
Yeah, that sounds right.
Yeah?
Yeah.
Okay, nice.
Exactly.
And then, this is a little bit familiar because I took discrete,
Mhm.
but at the same time I'm pretty new to, I guess, competitive programming.
Yeah.
I want to start learning in Python just to learn Python. I think that'd be a good initiative.
Yeah.
But I'm also taking Java because that's what we learn here
Okay.
at
Yeah,
FIU.
that's FIU.
Is there a like definite advantage of programming in Python, or is it just?
So in
that's what I've read.
like
but-
for competitive programming or interviews, or what do you mean
Yeah,
advantage?
for like leak code problems, really. And like I want to do competitive programming because
Mhm.
I'm a competitive person. I want to learn how it is, and it's fun mostly. But also leak code, I've heard you
Yeah.
want to put yourself in the best position.
Of course. I'll
I'm
tell
sure
you what I
can
told
sympathize with
everyone,
that.
and probably the best advice is use what you're comfortable with.
Yeah.
If you're really comfortable with, say, something like Java,
Well, I'm still learning Java.
You're still learning.
So I think, and I'm outside of class. I'm teaching myself JavaScript for
Mhm.
full stack or
Yeah.
front end right now, and then eventually full stack. So I don't want to but I still want to learn Python.
Yeah. I mean, take it step by step.
Yeah.
See where you're at.
Yeah.
But I'm not gonna say it's gonna be so much
Game changing.
easier or game changing, like you're saying.
Yeah, okay.
Whatever you're comfortable with is gonna work.
I'm just gonna go with Python. So
It-
I'll learn it. So yeah.
I will tell you that this is a Java school, so you'll learn Java anyways.
I know. Yeah,
Yeah.
that's a good point. Okay.
Recording stopped.
Thank you so much.
No problem. Thank you for coming.
Yeah, I appreciate it. Thank you for.
Hey, thank you. Thanks, Ricky. Thanks,
Thank you,
Yash.
Professor.
So I'll send you the PowerPoint slides sometime very soon.
Okay, that sounds good.
So that was a pretty good crowd.
Yeah. The room got filled,
usually.
and I saw
Yeah.
20 people on Zoom.
That's great. Yeah, that's great.
Room's been reserved. I'm pretty sure
Yeah.
you already saw.
Appreciate that, Dan. Yeah. Yes. I'll talk to you guys later. It's very late in the morning for me. I need to go have some sleep.
Thank you, Professor. Have a good night.
Okay. Take care.
Through Discord.
And become.
Since it's a 4 by 4 grid.
So anytime you touch the diagonal in